All right, buckle up, because today we're diving into the fascinating world of phosphorus,
Phosphorus.
an element with a past so wild it'll make your head spin.
And a present and future that are equally mind-blowing, I have to say.
We're talking secret societies, a rather unexpected key ingredient, and discoveries that literally illuminated the scientific world.
It's a story of how something most people probably never even think about, this element phosphorus, is both deeply intimate, like woven into our very DNA, and a potential global concern with this idea of peak phosphorus looming on the horizon.
Okay, so we've got a lot to unpack here. Let's start with, well, the beginning. The year is 1669. Picture this, you're Henning Brand, an alchemist on a quest for the ultimate prize, the Philosopher's Stone.
The Philosopher's Stone. Ah, yes, the mythical substance that could transform base metals into gold. It was a time when alchemy and early chemistry were closely intertwined, you see.
Right, like this mystical blend of science and magic, almost.
Exactly. The idea of transmuting matter, of unlocking hidden connections within the very fabric of existence, it captured the imaginations of many.
And in Brand's case, this quest for the legendary Philosopher's Stone led him to a rather, shall we say, unconventional source, human urine.
Now, as strange as that might sound to our modern ears, back then, urine was considered philosophically potent.
Philosophically potent. Okay, you're going to have to break that down for me.
Well, it was seen as containing the essence of life itself, you see. It was believed to hold a kind of inherent power.
I see, so not just, well, waste.
Not at all. It was considered a potential key to unlocking the secrets of matter, at least in the alchemical worldview.
So instead of, a fancy lab, Brand gathers over 50 buckets of urine.
50 buckets. That's dedication to the cause.
I can't even imagine the aroma.
I can only imagine it was quite pungent.
He starts distilling this, let's call it a unique concoction. And what happens? He stumbles upon a substance that glows in the dark.
It wasn't exactly a sudden aha moment, but it was certainly a startling discovery.
Imagine that you're distilling, well, and suddenly things start to glow.
It was a moment that challenged the very understanding of matter at the time. Imagine his surprise when he isolated this waxy white substance.
This glowing goo.
It had this otherworldly glow, and even more surprisingly, it would ignite when exposed to air.
Talk about a laboratory hazard.
It was both fascinating and dangerous. This substance he called Phosphorus mirabilis, the miraculous bearer of light.
Miraculous, maybe, but I bet storing it was a nightmare.
Absolutely. White phosphorus, the form Brand isolated, is incredibly reactive.
Like really reactive.
Even small amounts exposed to air can spontaneously combust. That's precisely why it later found use in, shall we say, less than peaceful applications.
Okay, so we've got glowing combustible goo. But wait, story gets even better. While Brand is busy with his unique experiments across the English Channel, another brilliant mind was on the trail of this elusive element, Robert Boyle.
Ah, Robert Boyle, a true giant of science.
Yeah.
Unlike Brand, Boyle was moving away from the mystical aspects of alchemy and towards a more what we would recognize today as a scientific approach. He was a meticulous experimenter.
A stickler for the scientific method.
Precisely.
And thank goodness for that, right? So Boyle, working independently, also manages to isolate phosphorus. And get this, he even refines the process, figures out that using sand could make the reaction more controlled, less likely to, spontaneously combust.
He was a pioneer in developing what we now call chemistry, a systematic approach to understanding the elements and their interactions.
So we've gone from glowing pea to controlled reactions only with phosphorus, am I right? But hold on, this whole urine thing still has me a bit baffled. How did Brand even get phosphorus from that in the first place?
It wasn't magic, I promise. It was a bit of fortunate chemistry at play.
Fortunate chemistry.
It turns out that urine naturally contains phosphates specifically, ammonium, sodium, hydrogen phosphate.
Okay, phosphates, I vaguely remember those from high school chemistry. Something about fertilizers, right?
You're on the right track. And this, my friend, this ammonium, sodium, hydrogen phosphate, was the key ingredient Brand unknowingly isolated during his quest for the Philosopher's Stone.
So it was the phosphates all along. Who knew that something we usually flush away held such a secret?
It just goes to show sometimes the most remarkable discoveries are hiding in plain sight. It just goes to show that the most remarkable discoveries are often hiding in plain sight.
So we've gone from glowing pea to controlled reactions, and it all comes back to phosphorus. But to really grasp what makes this element so special, we need to zoom out, look at the bigger picture, which brings us to the periodic table.
Ah, yes, the periodic table, the grand organizer of elements. If you have the excerpt we provided handy, you'll find phosphorus sitting pretty at number 15, represented by the letter P.
Element number 15, Phosphorus. Crebo. Got it. But it's not just hanging out solo, right? It's part of a group.
You're right, it's part of a group of elements with a bit of a tongue twister of a name. The pnictogens. That's group 15 on the periodic table.
Pnictogens. Okay. I'll admit the only one from that group I really recognize is nitrogen, crucial for plants, the air we breathe, the basics. Is it a coincidence that it's in the same group as phosphorus, or is there something more to it?
It's definitely not a coincidence. Phosphorus and nitrogen, they're like two peas in a pod, chemically speaking. They share some remarkable similarities. Both are essential for life as we know it, and both can form these incredibly diverse compounds with, and this is where it gets really interesting, vastly different properties.
Wait, so you're saying depending on how phosphorus is structured, what other elements it's hanging out with, it can completely change its behavior. Kind of like, oh, I don't know, a chameleon changing its colors.
That's a great analogy. Just like a chameleon adapts to its surroundings, phosphorus adapts its properties depending on its chemical company. It all comes down to how the atoms are arranged, how they bond with other elements.
Okay, so the building blocks are the same, but how they're put together makes all the difference. So what kind of different personalities are we talking about here? Give me some examples of how phosphorus can transform.
Well, we've already met one of its more, shall we say, flamboyant personalities, white phosphorus. The one Henning Brand discovered, the one that glows and spontaneously combusts. Talk about a dramatic entrance.
Yeah, not exactly the kind of element you want to invite over for a quiet cup of tea, is it? But seriously, these different forms, these personalities, they have a name, right? Something about allotropes. Refresh my memory. What are allotropes again?
You've got it. Allotropes. That's the scientific term for these different forms of the same element. Think of them like different outfits for the same actor, each outfit allowing them to play a different role.
Okay, so it's like phosphorus have a whole wardrobe of costumes, each giving it special abilities. So we've got white phosphorus, the dangerous one. What other outfits does phosphorus like to wear?
Well, on the tamer side, there's red phosphorus. This one's much more stable, more predictable. In fact, this is the workhorse you'd find in the safety strip on matchboxes. You strike it against a rough surface, and boom, fire.
Wait, so the match head itself isn't a ticking time bomb in my pocket. It's the red phosphorus on the box that needs that friction, that spark, to get the party started.
You got it. Red phosphorus is all about controlled combustion. It needs a bit of persuasion to ignite, unlike its more reactive cousin, white phosphorus.
Okay, that's reassuring to know. So white phosphorus, bit of a wild child. Red phosphorus, much more dependable. Are there any other notable phosphorus personalities, or should I say allotropes, we should meet? Okay, so we've got white phosphorus, a bit of a wild child. Red phosphorus, much more dependable. Are there any other notable phosphorus personalities, or should I say allotropes, we should meet?
We've got a couple more to round out the phosphorus family. There's violet phosphorus, which, as you might have guessed, gets its name from its, well, violet color.
Makes sense.
And then there's black phosphorus, which is kind of the cool cousin. It's actually stable, and get this, it conducts electricity.
Conducts electricity, really?
Yeah.
That's wild. I thought phosphorus was all about, glowing and fires.
Right. It's amazing, isn't it? Black phosphorus, it actually behaves more like graphite, the stuff in your pencil, than its other phosphorus siblings. It just goes to show how much variety you can get with just one element, all based on how those atoms decide to arrange themselves.
From glowing to conducting electricity, it's like phosphorus has a split personality, or maybe it's more like a multi-talented performer with a whole range of acts.
I like that, a multi-talented performer. And we haven't even gotten to its most impressive act yet, phosphorus's role in life itself.
Right, you mentioned that earlier. Okay, so we've covered glowing pea, matchboxes, even pencils. How in the world does phosphorus go from those things to being essential for, well, everything alive?
It all comes back to those phosphate compounds we talked about earlier. Remember how I said they were like the unsung heroes of life?
Yeah, the ones hanging out in our urine. Primarily.
Yeah, exactly. Well, those phosphates, they're not just hanging out. They're the backbone of some of the most important molecules in our bodies. DNA, for example, our genetic blueprint, it's built on a phosphate backbone.
So every time I look in the mirror and see my dad's nose staring back at me,
Yeah.
I've got phosphorus to thank for that.
You could say that. Phosphorus is essential for passing down genetic information from generation to generation. It's literally woven into the fabric of who we are.
Wow. Okay, that's pretty mind-blowing. What else? What other starring roles does phosphorus play in this whole life thing?
Well, remember those tiny batteries we talked about earlier, the ones that power every single one of our cells? The ones that keep our hearts beating, our brains thinking, our whole bodies
You're
running.
talking about ATP.
Right.
Bingo.
Adenosine triphosphate, or ATP for short. And guess what? ATP relies on a phosphate backbone to store and release energy. So every time you take a step, every time you think a thought, you've got phosphorus to thank for that energy.
Seriously, I had no idea I was carrying around this secret stash of phosphorus-powered energy.
Yeah.
It's incredible. Anything else? Or are we done with the phosphorus highlight reel?
Oh, there's more. Think strong bones and teeth. Those are built with phosphorus, too. Calcium phosphate. It's what gives them their strength and structure. And believe it or not, phosphorus is even involved in things like cell signaling, helping our cells communicate with each other, and regulating our body's pH balance, making sure everything is just right.
Okay, I'm convinced. Phosphorus is officially the most underrated element ever. But here's the thing. If it's so crucial for literally everything alive, shouldn't we be worried about running out? I mean, we're digging it up, using it for everything. Isn't there going to be a point where there's just not enough to go around?
That's a really important question, and it's something scientists are definitely grappling with. The idea of peak phosphorus, the point at which we're extracting and using phosphorus faster than it can naturally replenish itself, it's a real concern.
So like peak oil, but for phosphorus.
Exactly. The thing is, phosphorus is abundant in the Earth's crust. The problem is, most of it is locked up in rocks, not exactly easy to access or use. Right now, we rely on easily mineable sources like phosphate rock, but those are finite.
And we're going through them pretty quickly, I bet.
We are. Now, there's a lot of debate about how close we are to this peak phosphorus. Some experts think we're already there, while others say we've got a few centuries left. It depends on a lot of factors: how much extractable phosphorus is actually left, how efficient we get with using what we've got, and whether we can find ways to recycle phosphorus from waste streams.
Recycling phosphorus, that's an interesting idea. Is anyone actually doing that?
They are. Remember our friend Henning Brand and his unusual source of phosphorus?
Let me guess, they're mining sewage.
You got it. Some wastewater treatment plants are now equipped to recover phosphorus from sewage sludge, turning what was once considered waste into a valuable resource.
That's incredible. So from glowing pee to potentially saving the world, one element at a time. Talk about a deep dive. This has been fascinating.
It just goes to show that even the most seemingly mundane things, like phosphorus, can hold incredible secrets. And that understanding these secrets, it's not just about satisfying our curiosity, it's about ensuring a sustainable future for ourselves and, well, all life on Earth.
Absolutely. What a journey this has been from alchemists and their dreams of turning lead into gold to the very essence of life itself. Big thanks to our expert for guiding us through the ups and downs, the glows, and the less fragrant aspects of this incredible element.
It's been my pleasure.
And to our listeners, thank you for diving deep with us today. If this exploration has sparked your curiosity, be sure to check out our show notes for more information on phosphorus and the many topics we've covered. Until next time, keep those questions coming, keep exploring, and we'll catch you on our next deep dive.